Mirror, migration-related risks caused by misconceptions of opportunities and requirement.
While we wait for the slides, I will present myself. I'm Eric Elejalde. I'm also affiliated with the L3S Research Centre, which is part of the Leibniz University of Hanover. And we are also part of the Mirror project, so we are partners in the Mirror project. Now I will give you a brief introduction to a couple of the technologies that we used for network analysis, and this is our only some of the highlights, right? We do other analysis, but I'm going to present only two of them. The first one is bot detection. And the necessity for this type of analysis comes from the fact that social media platforms are flooded with bots, right? Maybe, as we saw before, not in all the communities, but in general, we say that there are an important presence. And I will not explain again what are the bots, but we can say the features of these automatic accounts make them an efficient way to communicate the message and quickly reach out to a large audience, right? The methods that are used in most cases for the automatic detection of bots are these black boxes, right? They produce a simple yes or no answer to the question, is this account a bot? So the problem with that is that we miss on other relevant information, for example, what kind of bot it is and why this account has been classified as a bot, right? Not all bots are, by definition, bad. There are many bots that do some type of works that are necessary. The ones that we want to identify are those that are not, they don't identify themselves as bots, and they purposely try to mislead other persons by making them think they are normal human users. So the approach that we used in our project was to define a new explanatory bot detection method for social media that is based on easy explainable attributes that we can observe from the social media. For example, the popularity of the account, how they interact with other users in the network, also the variety of topics with which they engage, but also having a set of reference accounts of different kind of bots that we already know that they have been classified as bots and also into different classes, right? For example, spam bots or porn bots. And the idea is to use these two things and detect various types of bots based on the similarity of the patterns of behaviors that we found in the accounts and see that they are similar to the ones that we already know. And also based on the most distinguishable features of these accounts, also motivate why they have been assigned to a particular class or a particular type. And we found that indeed different groups of actors or users or bots have distinguishable features that are significantly different between these different classes. And with these features, then we can characterize the different type of bots. How we can use this in Mirror? Well, now we can detect bots communicating migration-related messages, but also we can distinguish which kind of bots, of course. And with this, we can also identify topics related to migration that have an anomalous bot activity, right? And those might be of particular interest. But also at a more aggregated level, we can analyze certain narrative that might be emphasized or pushed by certain groups with the use of bots also in the context of migration, right? Now, the results from this analysis and some of the other analysis that we do in network analysis are presented in an aggregated way, right? With millions of social media accounts and, as Gara said, multiple other media sources that are producing content all the time, it makes more sense for the analyst to see at the data at an aggregated level, right? And we present this generally at the level of communities. So we also care about the aggregation quality, right? And aggregation is a practical and convenient approach to reduce the description complexity of the data and also reduce some of the redundant information. However, we have to be careful because bad aggregations might lead to unwanted information lost and then the misinterpretation of the data, right? For example, if we have a set of countries in a region or that has been defined by some other metrics, and we are looking at the behavior or the sentiment of these countries over time, then we can aggregate them by calculating the average, right, between them. And if they all have a similar pattern of behavior, if they are similar between them, then the average will give us a good idea of what is going on in the region. Okay? On the other hand, if the behavior is not homogeneous for all these countries, then the same average will not give us a good representation of the underlying data that we are analyzing, right? And this can lead the analyst to make generalizations for these countries that are not supported by the data. One solution would be to use microscopic properties or the hidden relations that we find and apply some graph analysis and clustering techniques to aggregate the countries, right? And then we could see that, for example, for the average sentiment in the mass media towards the EU, we can safely or more or less safely group Libya with other countries like Uganda or Egypt because they have similar patterns of behavior, but it would be not such a good idea anymore to group Libya, for example, with Tunisia or Mali, at least for this type of analysis, right? The problem is that in many practical cases, the abstractions that are needed by you, by the expert, by the practitioners, are built on macroscopic semantic concepts. This, for example, could be routes of migration or the main countries of origin or countries of transit, right? So this group of countries has already a semantic concept that we cannot ignore. And for that, what we did is we define an index which measures, which contains measures that has been inherited from information theory to quantify how good an aggregation is, right? And this index is basically a trade-off between the gain by the reduced complexity in the aggregation and the information that has been lost in the process of this aggregation, right? And in this way, we keep the semantic concept of the group, but also give back some additional information on the quality of the aggregation to the analyst that he can also take into account for the analysis. And with that, I stop here because otherwise...